Hello and welcome to this video on how to balance a redox reaction in acidic aqueous solution. Now we're going to learn how to solve these types of problems step by step, and the example we will be using is the one seen below. So the first step is to set up half reactions. Now we need an oxidation portion and a reduction portion. Now it's important to note that even though we are separating these into an oxidation half and a reduction half, this entire reaction is happening simultaneously. There's not oxidation then reduction. They're just occurring at the same time. So let me get my pen out because we need to assign oxidation numbers in order to determine which chemical species is being oxidized and which chemical species is being reduced. Now oxygen tends to have an oxidation number of -2. Now we have a total of 4 of them, so that gives us -8. What plus -8 equals -1? Well, that would be +7. I'm going to write that up here. There we go. Now, oxygen, once again, has an oxidation number of -2. -2 times 4, -8. What plus -8 equals -2? Well, that would be +6. Now, be careful because we have 2 carbon atoms. We need to find the oxidation number of each individual carbon atom. Since we have 2, we must divide by 2 to find that oxidation number of each individual carbon, which is +3. Our oxidation number of manganese is +2. It's given right here. Oxygen has an oxidation number of -2. 2 times 2 is -4. What plus -4 equals 0? I say 0 because this molecule is neutral. So +4. Let me keep that up there. Okay, so which portion is being oxidized, which portion is being reduced? Well, our manganese went from +7 to +2. We decreased in oxidation number, and in order to decrease in oxidation number, you must add electrons because electrons are negatively charged. So that's our reduced portion. MnO4 minus is our reduced right here to here. And our oxidation portion would have to be this one, but let's double check that. So our carbon atom went from a +3 to +4. We increase in oxidation number. In order to do that, we must lose negative charge, which are electrons. So our oxidized portions, C2O42 minus to CO2, and MnO4 minus to Mn2 plus, and that checks out. So step 2 is to balance each half reaction. Now follow these steps in order, the A, then B, then C and D, which is on the opposite slides. So the first step is to balance elements besides oxygen and hydrogen. And the reason that is because some problems, or most problems, have oxygen occurring in multiple chemical species and hydrogen occurring in multiple chemical species. So it's best to use elements besides oxygen and hydrogen. So for example, carbon in our oxidation half reaction. So let me get my pen out. So we have 2 carbon atoms right here. We need 2 carbon atoms over here, so we do that by adding a 2. Let's not worry about oxygen, we're worrying about the other elements. So manganese, there's 1 here, and there's 1 here. We're good to go. Now, let me bring down this 2 down here. So now we're going to balance oxygen by adding water. But before we do that, let's check how many oxygen atoms we have. We have 4 here, and by adding that 2, we also balance our oxygen. So that's pretty cool. Let's go down to our next problem, or our next half reaction. We have MnO4 minus, we have 4 oxygen. Now how many water molecules must we add to our product side in order to balance that 4 oxygen? Well, we need to add 4 water molecules because each water molecule has a single oxygen. If we add 4 of them, we now have 4 oxygen. But look, by doing that, we added more hydrogen atoms. So that's going to be step C. Step 2 of C of step 2. So balance hydrogen by adding hydrogen ions. So we already balanced our oxidation half reaction. Let's look at our reduction portion. So we added our water here. We have 8 hydrogen atoms. So in order to balance those hydrogen atoms, we must add hydrogen ions to our reduction, the reactants part of our reduction equation. So now we have 8 hydrogen atoms, or 8 hydrogen ions, and 8 over here. So we're good to go. Okay, part D says to balance charge by adding electrons. So this molecule over here has a net charge of -2, whereas our carbon dioxide has 0 because it's neutral. To balance this -2, we must add 2 electrons because electrons are negatively charged. Basically what we're saying is 0 plus -2 equals -2. Right there. And if we look at our reduction portion of our half reaction, we have 8 positive charge from our hydrogen ions. We have a single negative charge coming from our permanganate anion, giving us a total of +7. Our manganese over here has a +2, and then plus 0 from our water. So 2 plus 0 is +2. How do we go from a 7 to a 2? Well, we must be losing 5, or really gaining negative charge. So that would be 5 electrons. That's basically saying 7 plus -5 equals +2. Step 3 says we must multiply half reactions by whole numbers to balance electrons in the oxidation and reduction reactions. Well, our oxidation portion has 2 electrons, and our reduction portion has 5 electrons. To balance these electrons, we must have them equal to each other. And to do that, we must times our oxidation portion by 5 and our reduction portion by 2, because 5 times 2 is 10, 2 times 5 is 10. So that would give us 10 electrons. But be careful, you must apply this 5 to each portion in the oxidation reaction, and this 2 in each chemical species in our reduction half reaction. So 5C2O4 2 minus, 5 times 2 is 10 for the carbon dioxide, then 10 electrons. Then we get, for our reduction portion, 16 hydrogens. You get the point. All right, so step 4 is that we must add our half reactions and subtract species that are on both sides of the combined reaction. So let me get this pen out again. So what this is saying is, if we say added all of these together and we saw that a molecule occurs on both the reactants and the products, we have to subtract them. So the only molecule, but it's really not a molecule in this case, it's our it's a subatomic particle, which is our electrons. They occur in our reactant side and our product side. To explain this step a little bit better, I'm going to add some things to this reaction. So if we had a water, say 4 water molecules over here. Now this is just explaining step 4 a little bit better. So we have 4 over here in our reactants on our oxidation portion, but we had 8 water on our reduction portion. So we would have to subtract 8 minus 4 to get a total of 4 water on our product side. But that's not actually happening. That's just extending step 4. And same thing over here. Say we had a +5 hydrogen ions on, say, our oxidation portion. And remember, we had 16 originally over here on our reduction part. We would have to add those together. But that's not seen in this example, just extending step 4 a little bit further. So our total balanced equation is 16H plus 2 MnO4 plus 5 from our C2O4 2 minus, then 2Mn2 plus HH2O and 10 carbon dioxide. The reason why electrons are not appearing in this balanced equation is because they appeared on both the reactant side and the product side. Thank you for watching this video. If you have any questions, please comment down below.